permutations. We had defined earlier that the number of permutations of n different objects taken r at a time is given by npr. But this is not valid if the objects have to be arranged in a circle. For circular permutations of n objects taken r at a time, it is equal to npr divided by r, or we can say ncr into r minus 1. Selection is done in the same way, that is ncr, but the number of permutations will be r minus 1 factorial. Therefore, together ncr and number of permutations equals to ncr into r minus 1 factorial. Let's have an example. How can 6 people be seated out of a group of 10 people in a row and on a circular table? Consider 10 people, say P1, P2, P3 up to P10. Now selecting 6 out of them. It can be done in 10C6 ways. Consider one selection in which P1, P2, P3, P4, P5 and P6 are selected. Note that the following arrangements are considered to be different if the seating arrangement is done in a row, but they all correspond to one arrangement on the circular table. Therefore, the total number of arrangements in a row is equal to 10c6 into 6 factorial. And again, the total number of arrangements on a circular table is 10c6 into 6 factorial divided by 6, which is equal to 10c6 into 6 minus 1 factorial, that is 10c6 into 5 factorial. If clockwise and anti-clockwise circular permutations are considered different, then let's see what happens. On the left side, you have Amar, Akbar, Anthony, Akash, Raj and Ravi sitting in a clockwise fashion, whereas on the right hand side, you have the same people sitting in anti-clockwise fashion. You will note the difference between both the sitting arrangements is that on the left side, for Akbar, Amar is on the left and Anthony is on his right. Whereas in the right picture, for Akbar, Anthony is on his left and Akbar is to his right. So, if clockwise and anti-clockwise circular permutations are considered to be same, then the number of permutations is equal to NCR into R minus 1 factorial divided by 2. Let's have an example. 6 people A, B, C, D, E and F have to be seated on a round table. Then find the number of ways in which this can be done if 1. A and D cannot sit opposite to each other. 2. C cannot sit between E and F. Now let's see the solution. Of the part 1, we know 6 people can be seated on the table in 6 minus 1 factorial ways. Now since A and D cannot sit opposite to each other, so firstly we have to find the number of ways in which this is happening, and then we have to subtract it from the total. Now keeping A and D fixed in opposite positions, all others can be arranged in 4 factorial ways. So finally, the required seating arrangement can be done in 6 minus 1 factorial minus 4 factorial ways. Now the solution for part 2. This time C cannot sit between E and F. So again we will find the number of cases in which this is happening and then subtract it from the total. Now keeping C between E and F fixed in positions, all others can be arranged in 3 factorial ways. But one must note that there can be two cases of keeping C between E and F, namely ECF and FCE. So finally, the required seating arrangement can be done in 6 minus 1 factorial minus 2 into 3 factorial ways.